Okay, hello everyone. This video I'm going to demonstrate also one of your homework problem. It's the 12.9. Okay, yeah, this is also a beam, and this beam is subject to a shear force V, and the problem want to determine what is the maximum allowable shear force V? Okay, because he give you a constraint that the maximum allowable shear stress for the beam is 56 megapascal. Okay, so for this problem, actually, it's not the difficult problem, but I believe for the shear force in beam, you need more demonstration. Okay, so I draw the cross section of this beam to here, and also don't forget the relationship between the shear force and the shear stress bending transverse shear in the beam. What's the relationship? Okay, it shear stress equal to VQ over IT. Okay, don't forget this. Okay, so the next question is the largest shear force. Okay, the largest force and the max, and he said the maximum. Let's just give the maximum allowable shear stress is 56 megapascal. Okay, so the max is equal to 56 megapascal. And then you have to bear this in mind. The maximum shear stress is always at the shear maximum in a beam is at the neutral axis. Okay, don't forget this. The maximum transverse shear stress in the beam is always at the neutral axis. So in this problem, we need to identify the neutral the maximum identify the maximum shear stress at the neutral axis, and this is related to your Q. So that means we have to calculate the Q with respect to a neutral axis. Okay, so this is also affect the neutral axis. This also affect what your T is. Anyway, the first important issue is finding the neutral axis. First of all, find the neutral axis. Okay. And in this cross section area is not symmetric, so it's not that easy to identify the neutral axis. So you need to compute by yourself. That's the problem. So you need to compute by yourself. Okay, so this is a complicated shape. So first of all, we divide the shape into a simpler shape. So I divide it like this. We divide like this. Okay, and when you divide your complicated shape into a simpler shape, okay, then the next thing is identify the centroid of each area. So the centroid for each area maybe is here, and is here. Okay, so you identify the centroid of each area. So and then I call this is area 1, is area 2, and here is area 3. Okay, so first of all, let us identify the coordinate, the neutral where the neutral axis is. So and then we have three area, right? So we have three areas. So A1 plus A2 plus A3, and this is A1 Y1 plus A2 Y2 plus A3 Y3. Okay, so the next thing is what's our A1? Okay, so let's calculate one by one. What's our A1? A1 is 25. Yeah, this is a millimeter. Okay, it's 25 millimeter times the 75 millimeter. 25 millimeter times the 75 millimeter. Okay, and what's the value? So I just give you the value. Okay, so it's 1.875 times 10 to the power minus 3 is m squared. And what's the area 2? Area for area 2. Area 2 actually equal to area 1, so we don't have to calculate it again. Okay, m squared. And what's our A3 area for area 3? Area for area 3, so here is given here is 75 and here is 25. And so you will find it's the same. 75, 25. So you will find the same. So it's the same is equal to 1.875 times to 10 to the power minus 3 millimeter. Okay. Okay, so and next thing, what's our y1, y2, and y3? So it's the y coordinate of the centroid of each area. So what's our y1? Okay, our y1 is here. Don't forget, it's the area, centroid of area 1. So y1 is here. So here is 75. So y1 is 75 divided by 2 and 10 to the power minus 3. So it's 37.5. 10 to the power minus 3 meter. Okay, so y2, I believe y2 is the same. So 37.5 times 10 to the power minus 3. And what's our y3? Okay, so y3, be careful. It is the centroid of area 3. So yeah, I forgot. Our base is here. Is our base. Is our base. So here, so this centroid. So here is 12.5. And here is 50, right? Here is 50. So it's 50 plus 25 divided by 2. So it's 50 plus 25 divided by 2 and times the 10 to the power minus 3. So what's our, so it's 62.5 times the 10 to the power minus 3 is meter. So we will have A1, A2, A3, and we have Y1, Y2, Y3. So we can calculate the position of centroid or as the central the position of neutral axis. So our Y bar is okay. You will find the area is all the same. So it's 3 times 1.875 times 10 to the power minus 3, and okay, so it's 1.875 times the 10 to the power minus 3 times the y1. Okay, y1 is 37.5 times 10 to the power minus 3. Okay, and then we have 2. Okay, because I1, I2 is the same. So A1, A1, Y1, A2, Y2 are the same. So we just double the A1, Y1. And the final thing is A3, Y3. A3, I don't have space, so 1.875. Uh, okay, so I just put this in here. It's 1.875 times 10 to the power minus 3. And what's Y3? Y3 is 62 times the 62.5 times the 10 to the power minus 3. Okay. Okay, so actually, it's not that bad. It's not bad. It's not really difficult calculation. Okay, so what's your? So actually, it's 1.875 times 10 to the power minus 3 times the 3. So we can factor this out, and we will have 2 times 7.5 times minus 3 and plus 62.5 times 10 to the power minus 3. Okay, so cancel this out, cancel this out. So, okay, so finally you will have the answer. Yeah, I don't have space here. So it's easy to use a calculator calculation. So it will equal to, um, yeah, let me see. Okay, so it will equal to 0.04583. Right, but it's meter. Okay, so it's equal to 45.83 millimeters. Okay, so we had a position. We determine the position of neutral axis is 45.83 millimeter. So where is it? So be careful. Okay, so it's where is the neutral axis? So here is 50. So the neutral axis probably is, and here is 37.5. So neutral axis is here, I think. Is here. It's a little above the neutral x, the centroid of area 1, area 2, but it's not reach 50. It's not reach 50, so it's here. So here is 45.83 millimeter. Okay. So first of all, we determine the position of neutral axis. This is just the first step of this problem. Okay, so I just start a video here and it will continue in the next video, okay, because I don't want to make the video too long. Okay, so I just start video here and see you in the next video. Okay.